I know. Let's not even get into the college quarterbacks. So, hey, did you know this? Did you know that a quarterback can throw a football about 60 miles an hour? It's pretty amazing. That's about 27 meters per second. How about this? Did you know this? Football is released from about 2.2 meters from the ground. Hey, how about this? Did you know this? Yeah. I figured you knew that stuff. So check this out. So I'm going to take that. I'm going to take that 27 meters per second, the velocity. I'm going to take the 2.2 meters, the position that the ball is when it's released from the quarterback's hand, and the path of the ball along with gravity, and model it by this quadratic function. So just to break that down, this is gravity acting upon the ball. The 27x is 27 meters per second, and the 2.2 is where it starts out with. So if you plug in 0 for x, and you get 2.2, where it gets released. So here's a question. There's more to it than this. What's the instantaneous rate of change of the ball at x equals 1 second? So what we're actually going to do is we're going to find that, then we're going to write the equation of the tangent line. So let's find the slope of the tangent line at x equals 1, the instantaneous rate of change. This is the very first step. We find the average rate of change between x and some x plus h. So what you see right here is y2 minus y1 over delta x. So we'll simplify. Oh yeah, this is so beautiful. So one thing I want to point out is that this negative 16 is being applied to all three of those parts. This 2.2 is canceling with this 2.2, and so the 27x is canceling with this one over here because it's subtracting. Notice that this negative 16x squared right here is going to cancel with this one, so I'm going to skip that step. I'm going to take that out as I go to the next one. So I'm going to skip pages here, and then we're going to end up with just every single term is going to have an h in it. So here we go, negative 16 x squared, okay. Negative 32 xh minus 16h squared plus 27h all over h. Still average rate of change, my friends. Factoring out an h, and voila, we have that expression. I drew a green line because the next step is going to represent instantaneous rate of change. So we calculate the limit as h goes to 0. So negative 32 x plus 27. This is the instantaneous rate of change at every x value. So what is the instantaneous rate of change at x equals 1? So 1 second after the ball exits the quarterback's hand, that means that it's going to be negative 32 times 1 plus 27, which is equal to negative 5 meters per second. That's actually pretty interesting. So why don't we take a visual, get a visual of what that looks like. So I am just plotting 0, 2.2 right over here. And I knew that this point up here, I knew that anyway. So anyways, so I'm just going to sketch the curve. It's a parabola. So it looks something like that. That's the path of the football. So we go back here and we see that, okay, negative 5 meters per second. Okay, so that means that at time equals 1, which is right up here, that point, I could draw a tangent line, which means it's touching the curve at one point. It's sort of like a seesaw on the curve, yeah? And that means that the slope of that line is negative 5. And I can kind of see what's going on. Let's see. 1, 2, 3. Oh, the units are not 1 to 1. So anyways, slope of -5 is what that line is. So now the goal that we have is how do we write the equation of that line? Okay, not totally applicable to football game and what they need in the moment, but we know that the slope is -5. We know that the point is x equals 1. We know that this is the equation. So now we know the x value, we know the slope, we need to know a y value. So we take this x value and we plug it in to the function. So we get something like this. And we get -16 plus 27 plus 2.2, which is 11 plus 2.2, which is 13.2. Okay, wait, super. Okay, so we have an x value, a y value, and the slope. That means that we could just take all that info and do point slope formula. Y minus 13.2 equals -5 times x minus 1. That is the equation of the tangent line at x equals 1. So again, tangent means touch, and at x equals 1, that red line is touching that curve. Now, I know you're wondering, what's up with the normal? Well, I'm so glad you asked, because it's the English form of normalis, which is a Latin word for, oh I know, you know, perpendicular. So that tends to make it a little bit easy to write the normal equation. But hey, just so you know, this is all because this work was developed in the 17th century when European scientists still wrote about their ideas in Latin, which all of the Europeans could understand. So the normal equation, I know you want it. So let's go back here. We see that this equation for the tangent is y minus 13.2 equals -5, etc. So we're going to take that. We're going to use it. I think this is what I'll do. So I'll say m tangent, that's the slope of the tangent, is -5. So that the normal slope would be 1/5. So that means we have y minus 13.2 equals 1/5 times x minus 1. And just so you have them next to each other, y minus 13.2 equals -5 times x minus 1. No need, absolutely no need to simplify that. It's wonderful how it is, because we could look at these equations, we could see at 1 comma 13.2, the slope is -5 over the tangent line. At 1 comma 13.2, the normal is 1/5. So let's see that normal line. It would look exactly perpendicular to the tangent at that line. Sweet. Hey, while I'm here, I got a question for you. This is just a little challenge. At what time does the football have a slope of 0? I challenge you to find that out. We can see it. We can see it. It's somewhere to the left of that point that we were looking at. But that's all I got for you. Thanks so much for watching.